Welcome to this Deep Focus Explainer. Today, we are stepping into a serene, highly calculated space to deconstruct a foundational pillar of the Cambridge AS and A-level math syllabus. We're looking at Section 1.2, Functions and Graphical Transformations. I want you to settle in, take a deep breath, and let go of any exam anxiety you might be holding on to. Think of this as your lo-fi exam strategy session. A minimalist mental workspace where we don't just memorize formulas, we decode the very architecture of the Cambridge assessment structure. Did you know that mastering this single topic secures approximately 15% of your total examination marks? That is a massive yield. So we are going to calmly peel back the layers of filler words, isolate the exact assessment objectives demanded by the examiners, and figure out exactly how to map out those top-tier marks with total serenity. Let's take a look at our minimalist roadmap for today's structured study session. First, we'll ground ourselves in the core transformation principles. Second, we'll map out the method mark strategy. Third, we will mindfully navigate examiner warnings. And finally, we will elevate our thinking with critical analysis and evaluation.
Section 1, Core Transformation Principles. We begin our mindful deconstruction right here.
Let's look at our first core principle. Y equals f of x plus a. On the surface, it looks like a simple line of algebra, but conceptually, this represents a highly precise vertical translation. To truly master this without feeling overwhelmed, we need to apply the Zen of decoding command words. When Cambridge asks you to describe this transformation, they aren't looking for a casual observation. They want the precise terminology. You are taking the entire geometric function and shifting it uniformly up or down the y-axis. When you cleanly define this in your mind, you transform what looks like a complex visual puzzle into a single, highly predictable movement. Imagine a clean highlighter sweeping across the page, isolating just that plus a. That is your trigger. It tells you that the x-coordinates remain completely untouched, resting in perfect stillness, while every single y-coordinate shifts by exactly a units.
Now I want you to gently shift your focus and contrast that with our next principle, y equals f of x plus a, but this time the constant is tucked away inside the bracket. This is our horizontal translation. Notice how the shift operates internally within the function itself. It directly alters the x values before the function is even evaluated. It's a subtle but absolutely profound difference from our previous principle. Now let's think about how two different types of scholars might approach this. Imagine a student named Alex who is incredibly analytical. Alex sees this and immediately writes down the new coordinates. But then imagine Sam, who is highly creative but sometimes loses focus on the specific command word parameters. Sam might describe the movement visually, but forget the rigorous algebraic proof. Mastery here requires us to merge Alex's precision with Sam's vision. It requires evidence-based reasoning, knowing exactly why the graph moves left or right, and calmly proving it through your step-by-step working.
Let's transition our thinking to scaling. The equation y equals a times f of x represents a vertical stretch. Because the multiplier a is sitting outside the function, its energy pulls or compresses the graph straight up and down the vertical axis. Visualizing this cleanly is what allows you to perfectly map out the coordinates for your examiner. Think about the physical action of stretching a digital image on a tablet interface. The horizontal anchors stay locked in place while the vertical dimensions expand. Scaling our functions vertically requires the exact same systemic analysis as our translations. You don't want to rush this. When you see that multiplier on the outside, take a mental pause, confirm the operation, and write down the new y values with absolute quiet confidence.
Finally, this brings us to y equals f of a times x, representing a horizontal stretch. When the multiplier is inside the function bracket, the horizontal scale is fundamentally altered. Grasping this final transformation completes our core set. It empowers you to confidently target the highest cognitive domains of knowledge, application, and analysis. These four transformations, the two precise translations and the two precise stretches, are your primary tools. They are the minimalist building blocks you will use to construct flawless, high-tariff responses without ever running out of time or breaking your flow.
And this brilliantly illustrates our next major revelation, pulled straight from the pristine text of the principal examiner reports. The examiners explicitly state, quote, "Candidates referencing cross-topic connections achieve significantly higher marks." What does that mean for your strategy? It means that integrating these four distinct transformations with other syllabus areas, like trigonometry or calculus, is your serene path to unlocking the highest tiers. You don't just learn functions in a vacuum. You learn them as a universal, interconnected language that applies across the entire 9709 mathematics paper.
Section 2, the Method Mark Strategy. Now let's seamlessly transition into our technical methodology.
Let's step into a serene, collaborative study debate. Picture Alex and Sam sitting in a shared digital workspace, working together to assemble a model response paragraph. They use this exact 5-step procedural framework as their mental anchor. Step 1, identify key elements. Alex uses a clean mental highlighter to extract the exact parameters from the text. Step 2, apply relevant principles. Sam chooses the correct transformation based on the visual cue. Step 3, execute analysis with clear working. This is where they debate the structural framing of their argument. Alex maps out the textbook definition step by step, but Sam challenges the framework, ensuring they include a clear, logical, evaluative link back to the prompt. Step 4, verify results, a quick, mindful check of the coordinates. And Step 5, present in the appropriate format. They challenge each other's layout choices smoothly, writing out their sentences live to perfectly fit the mark scheme parameters. When you follow this flow, you calmly process data and execute clear working without ever rushing.
Here is the crucial insider secret. Examiners actually reward your systematic workflow. Method marks are awarded for a standardized sequence of systematic processing, not just the final conclusion. That logical, step-by-step working out is where the real, tangible value lies. Alex, our highly analytical student, sometimes crowds the page with unstructured facts and calculations. Sam, our creative student, sometimes jumps straight to the visual answer without proving the intermediate steps. In Cambridge exams, both approaches lose marks. You must view your exam paper as a pristine professional document. Your presentation of information must follow strict conventions, proper headings, correct terminology, appropriate formats, and crystal clear annotations.
Section 3, navigating examiner warnings. Let's breeze and refocus. Before we write out our final top-band paragraph structure, I want to make sure your daily study dashboard is complete. Subscribe to Ace the Exams at Ace the Exams right now, and enable all notification alerts. Whether your target is an IGCSE, an O-level, or an AS and A-level A-star, this channel is your weekly space for stress-free exam mastery. Now, let's mindfully examine the common structural roadblocks highlighted directly by Cambridge examiners and how to use the Peel structure, point, evidence, explanation link to calmly restore balance to your text.
Imagine our scholars encounter a structural roadblock mid-paragraph, where their evidence drops out of alignment. They check the top 3 mistakes from the principal examiner reports: confusing cause and effect, forgetting to check format and presentation, and writing answers not specific to the given context. Take a moment to internalize these errors. When Alex and Sam's paragraph breaks down, they step back and apply the Peel structure. They make a clear point about the transformation. They provide evidence by stating the algebraic change. They give an explanation of how that shifts the coordinates, and they link it directly back to the specific context of the question. This is how you purposefully avoid these exact errors when drafting your pristine model responses.
Let's visually separate cause and effect right now, as keeping these concepts perfectly distinct is a critical protective measure for your marks. Notice the distinct separation here. The cause is the precise algebraic manipulation, for example, adding a constant a inside the bracket. The effect is the geometric consequence, which is the graph translating horizontally. Examiners report that students frequently mix these up in written explanations, stating that a physical translation somehow caused the equation to change, rather than the mathematical operation causing the physical shift. You need to keep your logic flowing perfectly from the mathematical cause down to the visual effect. And right here, we have a direct examiner alert. The reports reveal that candidates consistently confuse key terminology. This vital alert reminds us to calmly establish our textbook definitions step by step before building any complex evaluative links. If a high-tariff question asks you to describe a transformation, do not just say, "It moved up." That lacks rigor. Use the precise vocabulary, a vertical translation by vector 0a. Writing out the response line by line in your mind using the correct format and appropriate terminology is a hard requirement for capturing those data interpretation and practical application marks.
Section 4, Critical Analysis and Evaluation. Welcome to the Visual Satisfaction Practice Arena. In our final structural tier, we elevate our focus to evaluative thinking. Let's open our first challenge, the mindful scan. Imagine a highly complex Cambridge source chart or text excerpt on your screen. You have a 60-second visual countdown timer ticking down softly. Your goal is to extract the single most high-yielding core trend. Top-scoring candidates master this comparative analysis framework to do exactly that. They use comparative connectives to logically map out both similarities and differences, supporting each with concrete mathematical evidence. If you are asked to compare a vertical translation and a horizontal translation, you must explicitly state what is similar. For instance, they both preserve the original shape, and what is different, which is the axis of movement.
Using terms like whereas, conversely, or in contrast proves to the examiner that you are executing a high-level comparative analysis.
Now for Challenge 2, the imperfect answer. Imagine a flawed student paragraph on the screen. Where does the structural discipline break down? To achieve true examiner compliance, you must look at your own work and calmly identify any limitations, assumptions made, or alternative interpretations that affect your final outcome. When evaluating your evidence quality, ask yourself, am I assuming this is a linear stretch when it might be nonlinear based on the function provided? Or are my drawn conclusions genuinely based on the evidence provided in this specific mathematical context? Questioning your own assumptions, calmly and methodically, is the absolute hallmark of a top-band response.
Alex and Sam now view their completed, flawless response paragraph on the digital notebook display as their focus meter maxes out at 100%. We've covered incredible ground today. Let's distill this entire masterclass into 3 core focus pillars. Pillar 1, the 3-step question scan, where we mindfully decode the command words. Pillar 2, the marks per minute flow formula, where we perfectly time our method marks. And Pillar 3, the final polish review pass, ensuring our terminology is flawless. Remember, mastering this mindful, systematic sequence around the 1.2 function syllabus secures approximately 15% of your overall grade for the entire 9709 paper. It's not about being the fastest mathematician in the exam hall. It's about being the most calculated, the most serene, and the most structurally sound. Before you close this explainer to practice your past papers, ask yourself, how will you actively integrate this 5-step procedural framework and terminology check into your next deep focus session? I challenge you to apply this exact calming methodology to extract every possible method mark today. And finally, if you found this session valuable, make sure to subscribe to Ace the Exams at Ace the Exams right now. Click the notification bell for future focus deployments, and leave a comment below identifying the specific subject, tier, and target grade you are currently meditating on. Mathematics is a journey of proving your logic. Keep your workspace clean, keep your mind clear, and I will see you in the next strategy session.